Hello guys, welcome back to the channel. It's Hash. Today I'm going to show you how to solve problem 4.42. It says draw the shear and moment diagrams for each member of the frame. Assume A is fixed, joint A is gonna be fixed, and B is gonna be pin and C is roller. This joint B is gonna be pin, so you have to be careful at this point. So in order to start to solve this problem, I have to first to find the reactions. I have to find the reactions. I have here a triangle, as you can probably see. This is 5, this is 3, this is 4. I'm going to find this angle alpha, okay? And alpha is going to be tan inverse 3 over 4, opposite over adjacent, which is going to be 36.86. So I can directly transfer the loads in the x and y directions without doing this inclination load. For this problem, in order to find reactions, since joint B is a pin, so we are going to have different way of doing it. We have to consider joint the member BC and member AB alone and find the reaction forces accordingly. So in order to do so, I'm going to distribute this load 0.5 kibs per feet over 8 feet. I'm going to have 4 kibs here. And let's get started. I'm going to start with member BC, the beam. I'm going to start with the beam. And yeah, I'm going to draw the beam and come back. I have drawn the beam. And now I'm going to distribute the load. I'm going to analyze or do some stuff for this load. I'm going to convert it into two loads, vertical and horizontal. This is going to be 20 cosine alpha, which is 20 cosine 36.86. This load is going to be 16 kibs, and it will act alongside the beam. It will act along like this, because this load is acting on directly the joint of the beam. Okay, and this is going to be 20 sine alpha, which is 12. Okay, this load is going to be 12 kibs. So we can easily find the reactions. I'm going to take summation of moments at point B. I'm going to assume counterclockwise to be positive. I'm going to have Cy times 12 minus 12 times 6 is going to be 0 and I can find Cy is going to be 6 kibs, kilopounds. Cy is going to be 6 kilopounds, and By rationally, since this acting on the front, this joint in the front of the beam, this is going to be minus 12 plus 6, which is 6. I'm going to delete this. And here, as far as you know, if we have 16 here, so this pin support, we are going to have a reaction to be minus 16 in this direction. And yeah, we've already done the procedure. I'm going to delete the angle and everything else. So let's draw the moment diagram for this beam. Let's draw the moment diagram for this beam. This will act in the front directly. Wait a minute. 12 kibs. And yeah, let's draw the moment diagram. I'm going to draw the shear and moment diagram for the frame. This is the shear diagram. Let's start with this point, joint B, plus 6. We got plus 6. We are gonna move until this point in the front of the beam. We have a change in load, minus 12. Minus 6 here. And we are going to move constant until this point. which is joint, we have plus 6, so we end up at 0. Okay, this is minus shear and this is plus positive shear. So in order to find the moment, or to draw the moment diagram, we have to find the moment. In order to find the moment, we have to take the area of the shear. As you can see, the moment is the integration of the shear diagram. This area is 6 times 6 over 2. 6, oh, not over 2. 6 times 6, which is 36 cubes feet. This same manner, minus 6 times 6, which is minus 36 cubes feet. And we will draw the moment diagram. It will be triangular. The moment is maximum at shear equal to 0. As you can probably see, we are preparing the moment diagram. This point is gonna be maximum, and the moment is gonna act like this plus 36 cubes per feet. It will act like a linear, is the integral linear. It will start from 0 at the support until the maximum at the joint, the front of the beam. This is our moment diagram, which is 36 cubes feet. And now we will go to the frame directly. I'm gonna add a page. I'm going to take this frame and I'm going to draw it first, and guys, I am back. So I've drawn the pin at B and fixed at A. Now I will have to find the reactions at the fixed joint support at A and at B. Initially at B, we are going to have the same reactions as we found previously in the beam, okay? But in the opposite direction. Since this is a pin support, is a link. It is like a bolt between member BC and member AB. So this is gonna be the same loads that we had in the beam, which is positive 16 in this direction, okay, and minus 6 in this direction, okay, opposite directions. This is always true and valid for frames in links or in any other support. We have here minus 6 downward cubes, and we are going to have opposite direction. Yes, we're going to have in the right direction 16 cubes. So we can easily find the reactions at support A. We have from eye inspection, I can agree, and I know that this is going to be 6 cubes, and this is going to be how much, which is plus 16 plus 4, like 16 in this direction and 4 in this direction. I'm going to get 20 in this direction by eye inspection, and I have to find the moment at point A. Moment at point A. I'm going to assume the direction of the moment to be counterclockwise direction. Why? Because these loads will cause a moment in this direction, counterclockwise. So for this reason, I know that I can use the moment here will be like this. What do I have? I have 4. Moment A is going to be equal to moment at A, this moment at A, minus 4 times 4 lever arm, and I have joint minus 6 will not cause a moment because it will act through the same axis of joint A, or the fixed support at A, so it will not cause moment. So I have minus 16 times 8 feet, minus 16 times 8 feet will be equal to 0. And the moment at A is going to be equal 144 cubes feet. 144 cubes feet. It will act this way. So now we are ready to draw the moment diagram. Okay, we are ready to draw the moment and shear diagram. I have prepared already the diagram, the graph. So let's get started. I'm going to change the color to make it obvious for you to understand. Now I will start from joint A. What do I have at joint A? I have plus 20. I have plus 20 this direction, plus 20, and I'm going to decrease until I reach, for this diagram, for this distributed load, minus 4 kips. So I'm going to decrease gradually minus 4 kips until I reach to plus 16 here, and then I go minus 16. We are going to decrease linearly, as you can see, approximately here, and this joint is going to be plus 16, okay, because 20 minus 20 minus 4 is going to yield 16, and I have here minus 16, I reach 0. So this shear diagram is completely correct. This is positive. In order to find the moment diagram, I have to find the area of this trapezoid, which is very easy. I'm going to find the moment. It's going to be the area, which is going to be 1 over 2, the two heights, 16 plus 20, times the length, which is 8 feet. 16 plus 20 times 8 by 2. I got 144 kips that feet. So now I will draw the moment diagram. I have here counterclockwise moment 144 kips that feet. So counterclockwise is negative. This point is minus 144 kips that feet. So how can I go? I'm going to go as usual, parabola. I'm going to go parabola. So I'm going to go like that. I'm going to go like this, approximately. But I can't draw it properly because it's hard, to be honest. Yes, this is our moment diagram. And thanks for watching. I'm going to check the moment diagram and come back to you. So thanks for watching, and I hope that you understood the idea of drawing moment diagrams for the beams. Actually, the moment diagram here is going to be something like that. Something like that. This is our moment diagram. And thanks for watching, and see you in the next video.